what are the chances that in production networks, they're using a little bit more than just ping messages back and forth all day? The answer is, of course, we're using lots of applications and services like HTTP and HTTPS and voice over IP and all kinds of things. Well, in Packet Tracer, we have the ability also to use something called a complex PDU, where we can generate that traffic, or we can generate it on our own from the desktops, and we can visualize that traffic as well in Packet Tracer. So to accomplish that, we're going to do three basic things. Number one, I'd like to introduce you to this option called a complex PDU. Secondly, we're going to set up our network that we've been building in this skill to add an additional web server, so I can walk you through exactly how to do that inside of Packet Tracer. And third, how we can visualize and see those packets with the simulation tool inside of Packet Tracer. So here is our Packet Tracer lab that we've built so far as part of the skill. And the icons, the link icons, were orange or amber, and they've now turned to green in most cases because spanning tree has converged. So we are ready to go. The first thing I'd like to do is let's add a web server. That way this PC here can actually connect to a web server, and we can then take a look and visualize or simulate the HTTP traffic going between the PC and that server. So to do that, to add a server, we're going to go down here in the bottom left, and we're going to click on End Devices. And then below that, we have End Device selected again. And then over here, we have some options. Let's select Server. And we'll go ahead and with that clicked, we'll go ahead and just drop it here on our workspace. And then let's connect that to the rest of the network. We'll connect it right into Core 2. So to do that, on the bottom left, we'll click on the Connections icon. And then over to the right, let's once again use the Auto Connect feature. And then click on Server 0. And then click on Core 2. And bada bing, bada boom, they are connected. So now we have a server that's connected to the network. Now, part of making this work is we need to have some basic IP connectivity, and we need to make sure that server 0 is running a web service. So let's talk about a strategy and a plan. We'll use the carpenter's rule. We'll measure twice, cut once, and then we'll implement IP connectivity and HTTP and then simulate that here in Packet Tracer. And to get us back up to speed, this is our network, the 10.67.83 network. This router is at .1, the PC is at .100. And for our plan, let's do this. Let's take the web server, which we just added right there. And let's give it the IP address of the network 10.67.83, those first three octets. And for the last number, it will be, let's go ahead and choose .5. I'm also jotting that down so that I can remember what that was. So let's make sure that we give that IP address to the web server. We'll also verify we have web services, and then we can go ahead and do a simulation of HTTP traffic and visualize that in Packet Tracer with the simulation option between the PC and that server. So back in Packet Tracer, if we want to configure server 0, we'll simply click on server 0. That brings up this pane just for server 0, and we are going to go to config, and down under interface we'll select fast Ethernet 0, and we'll give it an IP address that we just decided on, which is 10.67.83.5. We'll tab down and put a 24-bit mask of 255.255.255.0, which simply means that these first three numbers represent the network. These first three groups of numbers represent the network, and the last octet is representing the host of that server on the network. Super. Secondly, let's make sure it's running web services, because it's been scientifically proven it is not possible to successfully connect to a web server if it's not running web services of some type. So to do that, to verify services, we'll click on the Services tab, and by default, that new web server that we just added right here, server 0, it has HTTP and HTTPS on. That looks good to go. And one last thing we could do is let's go to the Desktop tab here, go to a command prompt on that server, and let's just do an IP config, which is a Windows-based command for verifying an IP address, 10.67.83.5. Let's also verify that we can ping the client, PC1 at 10.67.83.100. Survey says yes. Okay, great. We've got basic connectivity between server 0 and PC1. Now, I'm going to go ahead and close this window for server 0, and now let's do the simulation of the traffic. Now, there's a few ways of doing the simulation of more advanced traffic. So for the simulation of the traffic, let's go ahead and click on the simulation over here in the bottom lower right. And once we've clicked on simulation, notice that our event list filters, currently we're looking at none. And so if we want to see everything, we click on show all. We click again to go ahead and remove everything from the list. And if we just want to focus just on HTTP traffic that we want to visualize, what we would do is click on Edit Filters, and then from IPv4. We'd leave that all blank and go over to miscellaneous, and then they're alphabetical here. Let's go down to HTTP, which is right here, and enable that as the only item we want to see. So we'll close that dialog box, and notice down here we have event list filters, visible events, HTTP. Fantastic. Now, a couple of ways that we could generate the traffic. One would be to use this option right here, which is the Complex Pdu option. It works like this. We click on that icon, and then we specify where we want traffic to be sourced from. So if we want traffic to be sourced from PC1, we just click on it. That opens up this window. And with this window, we can then fill in the details. So instead of just doing ping, like a simple PDU, we have options. We have DNS and FTP and HTTP and HTTPS and so forth. And we could fill in all the details here if we knew the exact traffic that we wanted to generate. So the destination IP address, with that field selected, we could click on the server 0. It would automatically populate that address, and we put all the other details in. Now, one of the challenges with putting all this information in this complex PDU is that the average student, the average person may not know all the details that may need to go in. For example, we might just say, well, if we want to go to a web page, we just go to the PC and open a browser to the server, and that would do it. So we could use the Create Complex PDU as an option, or check this out, we could simply, I'm going to go ahead and take my mouse and go back to the Select tool to get off of the Complex PDU, or we could just go to PC1, which opens up a window on PC1, and from here we could go to the desktop, and there's an option right here for a web browser. So what we could do is just click on Web Browser, and then put in the URL. Now, because we only have IP addresses, we don't have DNS set up yet in this topology, we just go ahead and put in the URL, http:// and then 10.67.83. Looking at my notes, .5. Let me verify that IP address real quick. Sure enough, .5 is right there. Fantastic. So with that in, we'll click on Go. Now let me go ahead and minimize that window for a moment. And in the simulation here, if we click on the Advanced tab, there we have our first element of the HTTP messages being sent. So if we hover over it, it shows us that it's HTTP, and then we can cycle through it all the way. So the PC sends it on the network, the access layer switch gets it, it's going to go ahead and forward it through the switch network based on its MAC address table. In this case, it's going down to core 2, and then core 2 is going to forward that onto the server. And when the server gets that, if we click on that packet right here, check this out. This is so stinking cool. Here it has the inbound packet that was coming in with a TCP source port of 1026 and a destination well-known port of 80 for the web server, coming from the IP address of the client, going to the IP address of the server with the associated MAC addresses involved in that transaction. And for the reply packet, what the server is going to send back at layer 4, it's going to have a TCP source of 80 going back to the client at TCP port 1026. The IP addresses are also flipped, with the source going to be the server and the destination of the PC, and the MAC addresses are also going to be flipped. And because this is a switched network, there's no layer 3 hops in the path between PC1 and server 0. Server 0 is using the destination layer 2 address of PC1, and PC1 is using the destination layer 2 address of server 0. That's all reflected here as well. So we'll go ahead and close that, and then we'll cycle through the response, going back to core 2, back to the access layer switch, and back to the PC. Also, before I forget, I'm going to click on File and click on Save, because I want to incorporate this new web server as part of our packet tracer topology. So packet tracer has come a long way over the years. It's a great tool for learning, and I encourage you, as part of this skill in using packet tracer, I encourage you to not only have it installed, but to walk alongside me in these exercises to get the hands-on practice with it. Because that way, when you're learning something new or something different and you need to put a topology together in just a few minutes so you can practice it, you'll have that at your fingertips. It's going to be a great resource. So thanks for joining me in this video about complex PDUs and being able to take a look and simulate advanced traffic above and beyond just ICMP. And in the next video, check this out. What I like to do is we're going to take some physical hardware that's configured a certain way. Maybe you have some gear at work, or you're building a practice lab, or you've seen somebody with a practice lab of hardware, and you want to replicate that in Packet Tracer. We're going to take it from that approach, taking the hardware and replicating what they have so we can do the exact same tools and techniques inside of Packet Tracer. So I'll see you in that next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.